Okay, we're looking at number 12 because we decided that 10 and 11 were a little bit confusing because of double negatives, and we didn't want to add any extra confusion. So, looking at 12. This is like the pink sheet that we had for homework. Reading my question, it says 331 students went on a field trip. 6 buses were filled and 7 students traveled in cars. How many students were in each bus? So first thing I realized is that it says each bus. And when we did that foldable, we learned that each, per, weekly, monthly, those kinds of things all indicate multiplication and a variable. So I know that my buses will be multiplied, and I know that there were 6 of them. Okay, then if I'm looking at that sort of box method, right, it's the rate, which always has my variable included, and it's plus or minus my constant. That's the thing that happens only one time. And then some kind of inequality or equal sign, and my total. So reading again, 331 students went on a field trip. 331 is my total. 6 buses were filled and 7 students traveled in cars. 7 is my constant, and then my 6 buses is my rate, because I know that each bus, so something's happening to each of those buses. And I don't see any word that indicate an inequality, so it's going to be an equation. No need to model with algebra tiles. And we're going to solve here. 6x. Ooh, is it plus 7 or minus 7? Let's see. 331 students went on a field trip. 6 buses were filled and 7 traveled in cars. This is subtraction. So I'm going to be subtracting 7 equals 331. First step is add 7. And I'm going to do that to both sides. That's 338. These cancel, that's the whole point. And I bring down my 6x. Now I have 6x equals 338. Dividing by 6 on both sides is the only thing that gets rid of that 6. And then over here I'm going to divide. 338 divided by 6. 6 goes into 3 0 times. 6 into 33 is 5. And that's 30. Subtract, you get 3. Bring down your 8. 6 into 38 is 6 times. And that's 36. Subtract, you get 2. Here I would add a decimal because I don't have anything left to bring down, and add a 0. 6 into 20, 3 times, and that's 18. Subtract, oh, and I think I see a repeat. Yeah, because it's going to continue to ask how many times is 6 going to 20. So know that those 3 repeats. So x is equal to 56. 0.3 repeating, or 56 and 1/3. Now checking my solution would mean that I would plug in my answer for this x. I do have a little bit of a problem because if I use this decimal of 0.3, because it's repeating, it might be slightly off, but we're going to give it a try anyway, at least to see if I'm on the right track. Plug in 56. 0.3 repeating here, minus 7 equals 331. I'm going to pull to the side and work that out. 56.3 times 6. 6 times 3 is 18. 36 plus 1 is 37. 30 plus 3 is 33. I have one number after my decimal, 0 numbers after my decimal, so I need one number there. That's 337.8. So that's almost 339. If I rounded that to 339, that'd be 339 minus 7, 987, that'd be 332 is equal to 331. To be honest, that's as close as it's going to get because of that repeating decimal. If I subtracted this, it would be 330.8, which again, just because of that repeating decimal, I can't get an exact answer, but this is good to go. If you were really picky, you could solve it by doing 56 and 1/3 and check it that way. But who's got time for that? Probably nobody, right? But this is the only way you're going to get an accurate answer of 331 equals 331. To graph this, we can number however we want. So I'm just going to let's put 55 here, 56 here, 57, 54. 56.3 is going to be right about here, and it is a solid circle because it's an equal sign, and no arrows going left or right because it's not an inequality.